My name is Eric Allatta. I teach computer science at the Academy for Software Engineering. We're a relatively new school, but now we're in our 4th year, our first graduating class coming up this June, of a 4-year computer science sequence for an unscreened population of students here in New York City. I teach our Programming in Java course, which is a prerequisite to AP Computer Science in Java. I also teach a course that I'm going to talk about today called CS Principles. CS Principles is a new course, a new advanced placement course under development by the College Board. It will be the second advanced placement in computer science course. It does not replace the current AP Computer Science as a second course. It's designed to be a broad introduction to computer science for a broad population of students. The current advanced placement course is the second least taken AP course. And it doesn't reach a lot of students, and it tends to self-select for mostly males and mostly white or Asian students. We would like to expand the demographics by expanding what computer science can mean. AP Computer Science Principles will be live, meaning a live course that you can offer and that your students could get an AP credit for next year. 2016-2017 is the first year of APCS Principles. I'm going to talk about APCS Principles, and we're going to read and digest some of the documentation about it, assuming that we have no prior knowledge and that we've never heard of the course before. If you have heard of the course before, please share what you know. The reason why I'm doing the talk on this course is that I've been a part of the pilot program for developing that course over the past 3 years. That group has grown, but I've gone to the meetings and I've been a part of watching the course develop. What I can offer you today is the current state of the curriculum. It's still in draft form, but now that we're less than a year out, that draft will not undergo significant changes, I hope. But it has undergone some pretty big changes over the past couple of years as we've run the course in our classrooms and sent the College Board our student work, and that they think about what's actually feasible. All right. So a couple links that will be there later on, but what I'm going to talk from just a number of different tabs, and I have handouts of the different things that I'm going to put on the screen. I'll put them on the screen mostly to just so we're all on the same page about which document we're currently talking about. Before we get started, I'd like us to get to know who is in the room right now. So what I need is one person to be a note taker at your table. And let's see, we have 6, 7, and 4. Could we have a volunteer from each of the groups to come over? Maybe just one person from 7, and then we'll have 6, 6, and 5. Anybody? All right, please decide on a note taker now, and note takers, raise your hand. Note taker. Note taker. Thank you, Jeff.
I think I'm technically on the document right now, so I could be a note taker.
The notes we're going to take right now might not be the best for that document, but okay. Just take them somewhere.
All right, I have a note.
All right, ready? Here's your activity. Note taker.
All right.
Interview your table. Find out name, role, and fun fact.
Fun fact.
Name, role, and fun fact. You have 5 minutes, and then we're going to hear a report from the note taker on who's at your table. Not everybody here is a teacher, so just roll. Name, role, and fun fact. Ready? All right, go. And time. Table 1, table 2, and table 3. Okay. So we'll start with table 1.
I'm Jeff. I am a math and budding computer science teacher, and this morning I went to the wrong building. I was nowhere near here. This is Kate. She's from Codesters. She is working on teacher support. She's a former math teacher. It's a math hat on her computer. She's the winner of 5 amazing New York races, which are scavenger hunts. We've got Eric, who is a web developer and part-time teacher of CS, and he does a great monkey impression, which he has not shared with us yet. And we have Shirley, who is also from Coaster. She's a curriculum writer, and she does not know how to drive. This is Peta. She is a community manager at Google, focusing on diversity. She loves the water and goes on crazy excursions, but she cannot swim. And then we have Sarah, who is at a nonprofit called was at a nonprofit called Global Kids. She is currently working on her PhD at the CUNY Grad Center and recently learned how to juggle 3 at a time. And we have Lee, who is the education program coordinator at the Museum of Moving Image, and she told us that Yoda has 3 toes on each foot.
And number 2.
Us. All right. So we have John, who's a math and CS teacher at Park Slope Collegiate, and he's also a pilot of Small Flames. We have me, Tom. I'm the program director at Code Interactive, or CI, and I can walk on my hands, but I also haven't showed it to anybody yet. Maybe after PD. Karen is the tech coordinator at the school at Columbia University. She can bargain in Thai. Cynthia is one of the creators of the logo, of course. She's going to Thailand, and her feet hurt because the person she's staying with made her walk too much. Tracy is a steam engine or a troublemaker, and she made her visitor walk too much. That was good. Connections here. Michael is the head of the Logo Foundation, and he has known Cynthia for 35 years. Wow. Thank you. Okay.
All right, we've got Meg, who's a curriculum writer at Codesters, which is a platform that teaches Python, and she's a Mariners fan. We have Tiffany, who does Lego robotics at Gold Maple Academy in Queens, which is a middle school, and she's also a Mariners fan. We have Gordon Smith. He's the founder of Codesters, and he founded it in January of last year, but really 8 months before that, so he's been at it for a while. And his fun fact is he's turning 30, but he doesn't look it. 40. I'm sorry. I was trying to
Turning 20.
Next we have May, who's a learner, and she desires to learn, and she loves Minecraft. Then we have I actually, you weren't at our table. Do you want to give us your name, your role, and a fun fact?
I'm Jennifer. I teach coding, kind of K-11th grader, kind of the full spectrum. Fun fact, I'm hoping to go to the Berlin Wall this spring.
Oh, that's nice. We have Francisco Cervantes. He's a developer and digital learner manager for the After School Corporation, and he facilitates CS for educators in middle school, and focuses on underrepresented students. And he does a lot of fun things, and he became a U.S. citizen at SeaWorld.
Big congratulations. Like, did the dolphins swear you in?
They dip you.
That would be almost enough to get me to get my citizenship.
Right.
Almost.
I was 17.
And my name's Ashok, and I'm a professor at SUNY Old Westbury, and I just started teaching a few weeks ago.
Thank you very much. That's actually extremely helpful to me. We are from pretty much everywhere. Some people are working to develop curriculum or tools in the so the volunteers after school. Some people are in the classroom. So what I want to do is do an overview of the CS Principles curriculum framework, and kind of talk about what that is. Mostly, I brought you a lot of documents that we can parse together and use some of my experience, but mostly our ability to share and use peer instruction here. I'm going to hand out the materials now, so that in case you want to just go upstairs, you find you would rather be doing kind of thinking about a particular pedagogy technique, which is what Sean's talking about. then you can just grab my materials and go. So I'm going to tell you what I'm handing out, pass them out, and then go into the overview. I need a volunteer to help out here with each document, so I'll just so stand next to me while I talk to the group before we start handing out. The first document that I'm going to hand out, it's not this, is the description of the Explore performance task. What is that? What does that mean? What is a performance task? What does CS principals call it? Okay, the description of the Explore performance task. Thank you. I need another volunteer to help with my next document. Thank you. This one, and next I have 4. The next document is the description of the Create performance task, the second of the 2 CS principals performance tasks. You can just give, you can give 6 to a table, 6 to a table. I need a volunteer to help me hand out the third document.
Here, I'll help. Oh, great, you help.
The third document is the teacher's guide for implementing a College Board performance task in the classroom. Thank you. And my volunteer for the fourth document. The fourth document is the reference sheet that will be given to students when they take the AP exam. Extras? And actually, I need one more volunteer.
I'll do the same.
Thanks, Jeff. The final thing I'm handing out today are, this is very cool that we have these. These are a special print.
Yes, I'm sorry.
These are the CS Principals curriculum framework, all of the standards and objectives, including sample exam questions. Here's the overview of the rest of our workshop. We are going to read or skim each document, and then I'm going to prompt you for a 2-minute table discussion. Read through, skim through the next document, prompt for a 2-minute table discussion. Then at the end, we're going to play a game that I like to call CS Principals Roulette, which is find something in this really incredibly dense curriculum framework. All right, here's the overview. The National Science Foundation funded the College Board to develop a new advanced placement course. This is the first advanced placement course that the College Board initiated. Typically, they survey the one level of a college course, and they synthesize some kind of standards document for it, and then that's an AP course. Here, we are seeing a problem nationwide about participation in computer science, and we really, the NSF, really the federal government has an interest in affecting that problem. And the highest leverage that we have nationwide is the advanced placement coursework. So we have the CS Principals course. So they began about 5 years ago iterating on this set of standards, and then began piloting it mostly at the college level, where they got a few people to sign on, including like the University of Berkeley, or University of California, Berkeley. Then they began digesting this into teacher form and started piloting it in high schools. A lot of what we're doing is taking that college material and kind of seeing what it looks like at the high school level. CS Principals has 2 exam formats. One is a summative, objectively graded exam that's administered over 100 minutes in 70 discrete answer choices. It's either multiple choice or multiple answer choice questions. The second format of the assessment is called a through course assessment. You can administer it at any point in the middle of the course, and it's a performance task of the students. It's similar to the AP Studio Art course, where the students are developing a project that in class that they then submit as part of their final assessment. One of the documents I gave you are the guidelines, and I want to show you a little bit of what I've done to administer that, because administering performance tasks is probably going to be the single most difficult part of teaching this course.
Do you do both of the assessments, or do you pick one or the other?
You have to do both.
Okay.
There used to be 3. Now there are only 2, luckily. To administer the assessment, you have to provide the students with 15 hours of unassisted in-class time. That's for the create task. To administer the explore task, you have to provide the students with 8 hours of unassisted in-class time. That means your students have to be ready, both kind of in terms of expectations and the classroom is functioning, and in terms of their skill set, to take an idea and break it down and produce a document, but it also has to meet these requirements. So there's a bunch of prompts. We're going to be looking at those. All right, let's begin with the explore performance task. Find the document that says explore performance task. It looks like this. All right. We're just going to go quickly through all of these because we're very short on time. 3 minutes, just skim. Right? Read as fast as you can, but hit the major points in 3 minutes. Like that. Right. At your tables,
Yes.
what challenges might a teacher face during the administration of this task? I'll say it again. What challenges might a teacher face during the administration of this task? Alternatively, what preparation will students need to accomplish this task? Alternatively, what preparations might a student need to accomplish this task? Please discuss at your tables for 2 minutes. Note takers, get ready to share out. And we're back.
The question I'm always asking is what the teacher has to know.
So it's basically a term.
Let's start with table 3. Share out.
All right. We had a few different challenges. We had an administration task of administering the whole thing, and specifically network connected infrastructure, technical difficulties teachers might face. So part of what we were talking about was that this is an equity issue in terms of allowing students to have 8 hours in the class, but there's another equity issue of actually having the equipment in the schools. And so raising the infrastructure of the schools would be a challenge. And then our high school teacher Meg brought up that her students have trouble, typing and creating a response and citing a paper and citing sources and monitoring how many words they use and managing their time. All these things are things that you have to bring these students up to speed on before they can even begin this process.
Table 2.
We spoke about first motivation for students, making sure that the innovation that they're researching is relevant to their lives. Also technical difficulties. Tracy shared that she doesn't always have internet.
Yeah,
at
but
her
it's
school.
the middle school, so it's a little,
Yeah.
yeah.
But apparently high schools are that way.
Yeah.
Oh yeah, our high schools are like that too sometimes. And a lot of our students, like higher level, or some students have access to researching materials and internet at home,
Right.
and some do not. defining what is a computer innovation for students is something really necessary in background knowledge. And we spoke about teacher background knowledge as well. Like, are teachers prepared to administer this and lead students through this based on their own background knowledge? And we were concerned about the time necessary to do the whole task as well.
Table 1.
We said kids working at different paces on this 8-hour project might cause some conflicts in the classroom. Some kid might want to be doing a recording, and that's going to disrupt the other students that are working. It presumes a skill set that's not covered in the curriculum, like video editing, a lot of the other things that you mentioned. Sounds like you have to be dually teaching computer science history as well as computer science principles. There are some really big complex ideas, such as abstraction, that there may not be enough time to develop before you have the opportunity to give them the 8 hours, which may or may not be enough time to complete this task in class. The task itself is very dense. It's going to take at least a class period for them to understand what they're going to be required to do.
It does.
And the technology might not be available for some parts of the project.
Excellent. I'm going to briefly respond based on what I've done. I've administered the task twice to sophomores in high school both times. I think that it won't be a sophomore course when it's a live course. It'll need to be at least a junior or senior year course, because they do need a certain level of maturity to just organize time. Really just that one time management piece was the biggest challenge. To administer the task and to sort of support students through that challenge, I started 2 years ago with a document like this, where, which is the best one to show? Sorry, this one. On the class website every day, so like the home page of the class website was a Google slide. And all I would do is every day I would just move the first slide to the end of the deck. So it was just an easy way to update my website. And it had links to everything that they were supposed to do that day to break down the task. So like to give them the structure around talking to each other, I would have them complete a peer feedback survey where they would receive feedback, to write every day about what they accomplished, because part of the task is reflecting on your process. I would have them, this is for the next task we're going to talk about. But the basic idea is giving them a kind of a calendar of different parts of the task, and then giving them links that they have to accomplish for each day. And here's another way that I did that. Let's just open this one. Those same, here it is. So I would share them all on a Google Doc, and those same prompts that were on the website were in their document, and then they can, like every time they had to respond to a prompt, based on the schedule, they would just click on a link in their doc and it would like jump to that part of their doc. Just trying to give them a lot of structures so that all they had to focus on was the content. And then so now we're going to look at we're going to look at the next task, and then we're going to look at the teacher guidelines. You tell me, but I think that the teacher guidelines allow me to structure the students' time, right? Allowing them to just focus on the content.
Right, that's gonna be my question. Does this count as assistance?
Well, so you tell me. Right now, I think that I'm pushing the envelope in terms of helping students, but I think that depending on who your students are, you need to offer them more or less support around the time management piece. All right, the second piece was at table number 2, and then I'll take some questions. But the second piece around table number 2 was you need to prepare. What is a technology innovation? How do we connect it to our lives? And the way we did that was by doing many mini tasks where I would present an innovation, and then we would, as a class, annotate an article and then discuss and then do 1 or 2 prompts for that innovation, and then give them time each day to research, and then we would submit like a Google form, just like the basic outline of an innovation. And then at the end of our preparation, there was this big spreadsheet full of technology innovations that the students had kind of gathered together themselves. So there are ways that we can use all of that we're doing before the task. That's all good, right? They don't go into the task having never thought about this before. They've actually done the task many times before they go into the actual administration.
And they can refer to that.
And they can refer to that. They could use. There would be no way for me to stop them from using things that they'd already written,
Yeah, got it.
or had done something that they had already done. They've basically already done it. But when they go into the administration, it needs to be
At
kind of doing it
what point
afresh.
in the course is this?
I did it at the end of the. I've done it both times at the end of the first semester. So I use the end of the semesters as the kind of the time period.
What comes before?
So the end of the first semester, I'll just finish the first question. End of the first semester is the explore task, and the end of the second semester is the programming create task. And then that gives me the full year to do the programming instruction before they finally do the programming task, which I think it needs more time to develop skills. And then the first semester is the explore task. And so what comes before in terms of the explore task is sort of what I just described of we read articles in class, we discuss and annotate articles, and then write prompts, and then kind of review and get feedback from each other and from the teacher on all those practice prompts. I find I have a very good English department. I think my English teachers are doing great job teaching writing. So one of the best strategies that I can recommend for a teacher is find out, hopefully you have a good English teacher in your building, and find out what language they're using, and just use the same language. So that, because then if you use the same language, then they call up all of their prior knowledge, but they don't necessarily do that unless you help them connect to other instruction that they're receiving and other things that they're writing. Because they do have these skills, they just need to know that this is the same thing. Yeah.
Did you ever try this without the structure just to see how it would work? I mean, what inspired you to do the structure? Was it that you tried it without the structure?
That it's 8 hours of unassisted class time.
Okay.
I mean, I've never, typically, that's 2 full weeks. That was 3 full weeks. So if I went into the class and said, do whatever you want for the next 3 weeks, it wouldn't generally work. So I need to give them something to say, here's this big task, and here's sort of a method for doing it. Now, maybe
I almost wonder about that. Like, I bet you're right. Like, some students would have a lot of trouble with that. But I wonder if there's another side of it where some students would do something very unexpected and actually really creative, whereas they might not do it in the structure. I don't know.
And those students do typically not use my structures. So, but I do have to have structures because I want this course to be administered to all of my students. I really want the largest possible number of students to be successful.
I would use the structure too.
Yeah.
I doubt I would do it, but I was just wondering.
All right, let's go on because I do want to go through the next. Can you pull up the create performance task? That looks like this. The create performance task. Would you take 3 minutes to skim? Read as much as you can, as fast as you can through the create performance task. Sorry, I know that's not nearly enough time to read. I don't have a lot of time with you, so I just want to keep moving. Again, at your table, 2 minutes. What challenges might you face in administering this task, and/or what preparation would students need to be successful? And time? Let's start with table 2. Let's start with you guys.
Yeah, so we were just touching on that background knowledge of your programming language that you're working
Yep.
with. So I'm assuming you do Snap with BJC?
I did the first year,
Okay.
and I switched languages my second year.
Two.
Finish your thought, and
Okay,
then I will. No, I definitely want to talk about that, and I think that choice is really important. Go ahead. So what do you think is challenges or
Also,
preparations?
background knowledge, like we mentioned before, with video creation and editing. A lot of definitional background knowledge, so algorithms, abstraction, being really comfortable with what they are, how to create one in your programming language. Then we went back to motivation, really getting students to connect their own lives to this, getting students interested in creating something meaningful. And we came up with the suggestion of a more interesting prompt, perhaps.
How was it table 3?
So we thought that there were some teacher challenges in terms of rubric. We wanted to see.
I didn't provide for you today because my printer ran out of paper, but there are rubrics.
Oh, okay.
Yeah.
That's good. So yeah, that was one thing, and then we were thinking teachers would have challenges. They have to come up with video production, for example. I thought it was a little bizarre. The abstraction square really implies something very specific about the abstraction. It's all in one part of your code, and it's something you can circle, and it's nice and neat and tidy, which may or may not be the case. The students, on the student side, collaboration is super important, we all agreed, but how it was talked about in here was vague. And then how are we going to come up with ideas for this to meet the requirements? Because the requirements are you have to use all these aspects of the programming language, and it has to be something that's like non-trivial for computing, I guess. And how do you get the students to get to the point where they can create something like that? Isn't necessarily clear. And then we had an idea of some students are going to come in with pre-existing coding experience, and some students might not have that experience. And so, how do you make the class or tailor the class for all of these students? And we had a thought that maybe students are facile enough these days that could work out.
Thank you. And table 1.
We had questions about the level of complexity required for the program. It seemed a little bit vague, as well as the focus of the program. Does it have to be academic? Can it be fun? Can you build a game? Creating structure about appropriate ways to work independently versus collaboratively. It would take a lot of time to build those skills with the students, in addition to what it looks like to give useful peer feedback. Will they be graded on their peer feedback? Structures about using video to explain the functions versus going line by line. This is also a skill that has to be developed with the students. And some uncertainty about when the collaboration would happen during the project. It seemed to some of us that it would have to happen at the beginning to get the brainstorming started. But if some students aren't ready for it, it just may not work out all that well. And will they have enough programming skills by the time they're supposed to start this? And it was unclear what languages you can use. Can they use a block language like Scratch, or does it have to be something else?
Okay. I find that the most difficult part about this task is students need to ideate an original program concept, plan an implementation of that concept in an allotted period of time, right? Get feedback, and then document the entire process plus parts of how their code works, including making a video. So it's really a very heavy cognitive load, and it needs a lot of preparation. So some things that I've done, in the first year we used Snap, and is there anybody here in the BJC, the current BJC teaching pilot?
Oh, no.
Sorry, there's a group that's currently doing PD. Tracy's doing the BJC on the MOOC. There's also so BJC I'm going to speak a little bit about the different offerings. This is probably a good time. CS Principles is being offered by different organizations as packaged curricula. The Beauty and Joy of Computing is a course offered by the University of Berkeley. There's Mobile CSP, which is based on, what's it called, App Inventor. They use App Inventor. There's Project Lead the Way, which does it through web development. I've been working with Emmanuel Schanzer and the Bootstrap group to develop a Racket and Pirate-based CSP. It's language agnostic. You can teach it in any programming language. That means that you as a teacher can follow whatever your pathway has been and then offer that course in that same pathway, or whatever works best for your students. So if you have that group of students who have come in with prior programming experience, you can tailor it to their needs. We will look at, there is an exam, and the exam has a pseudocode language. You will have to expose them to that in order for them to be successful, but you can do most of the course in any language.
I'm really confused. This is something you did. This is what you did, and I'm confused by you're saying you're part of the Northeastern folks. I can't remember what you Bootstrap was designed at Northeastern.
Yeah.
And so is this part of the Northeastern package, or?
Good. I understand your question. Computer science principles is, and maybe, I think you're probably right, I didn't do a good job laying the groundwork. Computer science principles is only a curriculum framework and a set of assessments. I think the next one we should do, we should crack this open and take a look at it. It's a set of learning objectives and big ideas of computing that are assessed, the student's exam. So it's an advanced placement course, which means it has an exam, and the exam is both an end of the course objectively graded exam, like a multiple choice, and a through course performance task.
Do these two things go together? This cluster of material and this goes together?
That's right.
Okay, I didn't understand that. And then what goes on before this is open.
Exactly. So I presented the tasks first because I was letting that be an open question that we could bring all of our different experience to.
And
your students will have to achieve this.
I want to know, did you make these up?
I did not make those.
You
Those are
didn't?
from the College Board.
Those are from the College Board.
Yeah.
That's the test the students have to
They
take.
should flunk.
Well, I mean, just out of curiosity, what's the biggest problems with those?
Huh?
What are you finding problematic
Well,
about it?
all the things you said, but more. It's boring.
I was thinking
That's a deal breaker.
Computing is exciting,
Right.
and the tests ought to be match
Welcome
that.
to education.
Well,
Right.
I mean, just to play devil's advocate, so it's implementation agnostic. You could make an exciting implementation if you're a teacher, right? Like if you did it, I'm sure it would be exciting, but
Well, I thought there were 5 competitors
Okay.
in this game. There was App Inventor, Scratch,
oh,
Snap,
okay.
and then 2 other things.
So those were like kind of the implementations that were
that
expected.
NSF was decided to support
I see.
Snap, Scratch, and App Inventor.
Oh, I didn't know that.
Whoever's doing that research in those, and he probably knows more. Then there were other 2 I didn't know, but I read that NSF was supporting those 3, which shocked me because they're all, it's like kind of involuted. I mean, Scratch and Snap are similar.
Right.
And App Inventor is Hal Abelson, who was part of Logo. I mean,
Yeah. It's all,
Just-
it's all
And they're cousins.
So it's, as a teacher implementing the course, I think you can make this exciting. I think that when the students get to the task, they can be poised and ready and want to produce something. I found that the structure of the task gives them a way to come up with a final product that can be pretty impressive. So I did want to show some student work. I also am running short on time. So a student, I got a lot of choose your own decision-making SNAP programs the first year. You know, what's your name and how many hours of sleep did you get? But I don't have enough sleep, so I have to fix that. So students are writing programs in SNAP. The next year, I went to a language that's brand new called Pirate, that is a sibling of Racket. These are the languages that are taught by the Bootstrap curriculum.
PYRIT or
PYRIT, yeah, pyrit.org. I'm not pushing any one language or implementation. I really think teachers will find a curriculum and find a language set based on their unique pathway into computing teaching.
I think that's, shut up.
And then you'll administer this course, and you'll prepare your students to get that advanced placement credit, which is really good for them to have. Here in New York City, that will kill two birds with one stone for you. It'll both help your school administer an advanced placement course and administer in a computing course. So it's a great course to take up and to explore more about and find all the different ways that you can implement it. Let's go to the curriculum framework. So here is the set of knowledge and skills objectives that students need to cover throughout the course to be ready for the exam at the end and to be ready for the performance tasks. Take 3 minutes to flip through it. And time. I wanted to show you one more thing. I did have students, my second year I had students make the video. The video actually is not that big of a problem. We use screencast-o-matic.com, and they just record a video of their screen while their program is running. That takes only a few minutes, and they do it right away. So where I thought that was going to be a big, I had to teach them how to do it, it turns out that was not where I needed the instruction. Here's a video of a student program from the second year using Pirate. When the space bar is clicked, a random shape is seen on the screen. This student's program is, I don't want to put ideas in your head, but it's in some way less interesting than the more interactive program that would help somebody develop better sleep habits, right? Where that one student had kind of an idea, like I want to help people develop better sleep habits. I'm going to write a program that kind of solves that problem. This program is far more sophisticated in terms of its algorithm, in terms of what's behind it. So this student using Pirate recursively walks over a list with a random base case and returns an item. That student did a lot of problem solving and whiteboarding to develop that using the instruction we had done in class. And his video is just as good. Like his outcome is wonderful. The creativity can be kind of on either end. And both of them are good outcomes of this course. But I love that the course enables students to find things that they're interested in, and then use whatever the class has to offer.
Do they get comparable grades?
They would get comparable grades, yeah. Okay. So we have just a couple minutes left. I wanted to play, curriculum framework roulette. I'm going to call out a knowledge objective. And I'd like you to try to guess, or try to find, but I'm only going to give you a time to guess, what big idea it comes from. So let's just review. The curriculum framework takes computer science and it presents it as 7 big ideas. Could somebody share with us what the 7 big ideas that the curriculum framework presents are?
Creativity, abstraction, collaboration, data and information, algorithms, programming.
Now back.
The internet.
And
Global impact.
global impact. So it breaks it down into 7 big ideas, and each big idea has essential question statements, enduring understanding statements, learning objectives, which are pretty general, and then each learning objective has specific knowledge objectives broken down. It's pretty helpful that it's broken down into this much detail. It helps me in my curriculum mapping. It helps me in the documentation that I've been asked to produce. So that's nice. It's not specific enough to be. I have to then use this to plan my course or to write learning objectives for my course using whatever implementation or programming language I've chosen. But it gives me a good idea, and I like to try to align as much as I can. If you've chosen a curriculum like BJC, by following their curriculum, you are covering the learning objectives. That's what they're saying to you when you choose that curriculum. But this is what ultimately we're held to as teachers of advanced placement computer science principles. All right, so here's a knowledge objective. Determining an algorithm's efficiency is done by reasoning formally or mathematically about the algorithm. What big idea is that about?
Algorithms?
Determining an algorithm's efficiency is done by reasoning formally or mathematically about the algorithm. Algorithms. Here's another one. I won't show you what I'm looking for. Large data sets include data such as transactions, measurements, texts, sounds, images, and videos. Big idea.
Information.
Come on.
You all just got 4 credits.
Duplicated code can make it harder to reason about a program. Is it programming? Is it abstraction? In this case, it's programming. Okay. Should be abstraction. When you begin to parse this, you notice that you're teaching abstraction concepts and programming concepts at the same time. That's actually what I found is the most challenging about using the learning objective at the same time while I'm teaching. I'm usually teaching a lot of different things. We're doing a lot of different things at the same time. So it's broken it down, though, in a way that I think is a helpful vocabulary for us all to have. Like as we're discussing what's happening in our classrooms all look very different. But if we have this curriculum framework kind of as a common language, it could be helpful. I want to stop there. Were there any other questions that we had that I could help with today, or that we could help each other with?
Are the rubrics on the APCS website?
They are not.
Yeah, I don't see
They are not. I do have them though, and I'm going to put them into our document for today. We did not get to the guidelines, which was the implementation guidelines. Actually, do flip to the implementation guidelines. There's one thing I want to show you about implementing. There it is. So this document that says implementation guidelines, can you all look at that? And can you flip to the last page? To these diagrams? I'll wait till everybody's there. You see those diagrams?
Yes.
All right, here I want to talk I want to tell you about the development of the course, how it's changed. This is the only thing I'm going to say about how it has changed. Originally, students had to work together on a collaborative program where the outcome, the program outcome was theirs as a shared product. And they had to make an individual program. So they ended up having, they had to actually make 2 programs, but that turns out to be really too much to try to do in any time window. So what they've done is they've narrowed it down to a single program that you must collaborate on. That means at some point you have to seek feedback and get that feedback. Now, in the guideline, they presented some possible models for how students might do that. They might use this model that I'm showing on the screen, right? Develop 2 parallel programs, but share kind of an ideation phase and then share some kind of testing phase where they might test each other's programs. In the curriculum that I use, students write a lot of unit tests. So they're developing functions by writing examples of those functions. And students could write examples for each other. Like here's a, given this is the function that I'm intending to write, here's my signature. Could you write examples for me and make sure I'm testing it well? That's what I'm going to do this year. That will be one way of collaborating. Other ways of collaborating that they show, but this is not exhaustive, could be that 2 students develop exactly the same program. Like they actually work on the same program for a while. Right? Like get like the same foundation, get it off the ground, and then they split. Maybe one does level 1, one does level 2. Maybe one does just a totally different feature add or something. The students can use a whole bunch of different models, and you can guide them as part of the instruction. You would be talking about collaborating. I use pair programming for most of my course. I think 2 students working at one computer is a very strong way to have them solve problems. But whatever you do in your course to have students collaborate, they can use that when they're developing their performance task program. Thanks, folks. That's all the time I have. Please email me if you have questions. Reach out. I'd love to help people.